Welcome to a testing video from the Ultralight Airplane Workshop. Typically, I like to do some analysis on a structure, then build it, and then test it. But in this video, actually it's going to be a multi-part video, we're going to do it the other way around. We're going to build something, test it, and then do analysis on our testing. And then we'll use that analysis to design a rib for the UWS-4 Ultralight Airplane. Now, the type of rib I would like to design is a cantilever style rib. And by cantilever, I mean that the rib is attached to the spar. Now, this is the shape of the nose rib for the UWS-4 Ultralight. So this would be the back of the nose rib attached to the spar, and the skin would be attached to the rib, flanges that would be bent on the rib. And by cantilever, I mean that that's all the rib is. So there's force up and down out here, but it's being held back here. Now with the truss style rib, that would be slightly different. And here's a truss style rib. Now this is a ultra cruiser rib, and as you can see, it's got this brace piece here, and so this is more of a truss style. It's still attached back here, but it's using this truss for the strength. Whereas in a cantilever style rib, this is acting like a beam and holding the load out here, and this is acting like a beam holding the load out here. So they're sharing the load. Now for the UWS-4, I've done some calculations in another video where I determined the worst case force that this nose rib has to handle and what the moment arm for that force is. Now that worst case is when we are the N1 condition, and that is at a load of 3.8 Gs, and that will be on the center section of the wing fairly close to the cockpit. Now in that case, the load on the nose rib is 61 pounds and it'll be pushing up, and the arm for that load is about 12 inches forward of where we attach to the spar. So I want to design a rib that can handle that load. Now I should warn you up front, in this part A of this little video series, we're not going to get into the testing yet. This is really just an introduction to explain things so I don't have to do it in part B. In part B, we'll be doing some testing and we'll probably get to analysis. I don't know yet. The results of what I'm going to do with my initial parts will determine whether there's going to be a part C or not. I may not be happy with the results and I'll have to make some more parts and do some more testing. So the most force that's going to happen with this nose rib is right back here. That's where the moment is greatest. So on my initial testing here for this rib, I'm going to emulate just this portion of the rib and this portion of the rib and make sure they can handle that 60-pound force out here at this point. Now since I'm only interested in testing this corner of the rib and this corner, that means I don't have to design an entire rib and fabricate it and do testing on it. That'll save me some aluminum, it'll save me some time. So basically, this is what we're going to have then. So this is emulating that little portion of the rib. So this would be the top portion, this would be a bottom portion. But I'm going to test them separately. I'll test a portion of the rib with a load going this direction. Then I'll test another portion of the rib with the load going this direction. Now the actual load on the rib is the other way, but I'm going to use gravity to help me do the load. So it'll be down. I know what loads the rib has to handle. I just don't yet know how to design that rib to handle those loads. So that's what the testing is going to help me with. I've formed up a number of the corners that I'm going to have for the rib in different shapes. And I'm using the Ultra Cruiser rib as a starting point. So this rib has 1/2-inch flanges to attach to the wing skin, and it has 1/2-inch flanges to attach to the spar web. So I've made a number of forms here that have that same form. So there's 1/2-inch flanges here, I've only put 1/2-inch web here, and then I've put various lengths of bent flange out around here. Now this particular case, on this one, I have a 1-inch radius in here, and the bent flange here is 1/4 inch width. And the angle of the bend is around 30 degrees. I have another one here that's similar, except it's got a 2-inch radius here. Now I made a little bit of a mistake when I was making this, and so my flange here isn't a 1/4 inch, it's closer to an 1/8 inch. So this probably won't work, but I'm going to go ahead and test it anyway, just to see what happens. But I'll have to make another one that has the correct flange width of a 1/4 inch. And then I have another one here that has a 1/2-inch flange, and also still a 2-inch radius here. So I'm going to start testing with these and see what works, what doesn't, what can handle a greater load. So obviously this is going to be heavier than this just because there's more material here. I want the rib to be as light as possible, so I'd really prefer this to work, although I happen to know that it won't. And the reason I know that is I've already done a little bit of testing. Now all these that I've just shown you are made out of 20 thousandths thick aluminum, 20 thousandths of an inch. And that's because in a previous video, I figured out that on the main rib, up here near the nose, if I want to have a fairly wide spacing, I'm going to have a fairly thick flange here to keep the rivets from pulling through or at least deforming the flange, just because of how much load there's going to be on those rivets from the skin trying to be sucked off the nose of the rib. And that was just kind of testing my process, making sure my rig setup would work. So I did quite a few tests, just having some fun playing around with it. But I'm going to have to do some more stringent tests here in the next part of the video. So briefly, just in case you're curious, I thought I'd tell you a little bit of how I made these. I'm not going to go into a lot of detail. It's been 20 years since I did aluminum forming, and so I'd like to kind of get back up to speed on it again before I make a video talking about how to do it, at least in detail. But I'll give you a brief overview here. I first cut out the aluminum sheet using a form like this. So I cut out some aluminum a little bit bigger than the form, and then I use a router with a straight bit on it, a carbide bit, to go around and route out the shape. So I've got several different forms for that. And by the way, while it's on the form, I use a bolt through a registration hole to hold them in place. And then I make another, which is the form to bend the sheet over. And it has the same registration holes. Although I obviously made a mistake on this, so I'll have to go back and see where I went wrong on that. So essentially, I put the sheet over it. I use a rubber mallet to bend at least a crease line on here. When I just had the crease line, so it's just barely bent down a little bit, I have a Panam box brake that I use to go back and bend these to the 90-degree angle that I want, so a Panam box brake works great for that. But since we've got this curve in here, I use the mallet to go ahead and do that. Now in this curve, I actually use the curved part of the mallet to beat in here, and then out here I use the flat part of the mallet. And one thing I did not know, and I was trying to find and couldn't really find a good resource for, is what radiuses I should use and what flange width to use. So I figured out the hard way one thing not to do, and this is with the 16 thousandths thick aluminum. It may be a little bit different on the 20, I haven't tried that yet. But with a 1/2 inch flange and a 1 inch radius here, that doesn't work very well at all. I started to get crinkles right in here when I was doing it. So that combination doesn't work, so I know not to do that. But as you can see on these, at least these 20 thousandths thick ones, in fact, here's a 16 thousandths thick one. I can do a 1 inch radius here with a 1/2 inch width for the flange. And on these 20 thousandths, I went up to a 2 inch radius in here with a 1/2 inch thick flange. And that works pretty good. I got a nice flatness in here, so I'm liking that a lot. Well, now let's talk a little bit about the process I'm going to use for the testing. Now, as I said before, I'm going to test in 2 orientations. In this orientation, where this is the bottom corner of the nose rib, and then in this orientation, where this is the top corner of the nose rib, what I want to do is put some weight out here. And the way I'm going to do that is I'm going to take this little piece of aluminum, I'll drill a couple more holes in here, and I will rivet this onto the aluminum rib. What I can then do is put a weight out here, or in this case, this direction. Now by itself, this rib isn't very strong. It's got plenty of flex to it. What I really want to do is simulate attaching it to the wing skin and a spar. And that's what this little fixture is for. So this is going to act as a wing skin. This back here is going to act as a spar. This is the shear web for the spar, and this is just to help stiffen it. What I will then do is I will drill holes. I've already got some holes here in the skin and the web. I'll drill some holes in my rib, and I will rivet it into this attachment. I will then put this stiffener here in a vise, so that will hold it rigidly either in this orientation or this orientation. And then with this attached, I can put a weight out here. And I'll keep adding weight until it fails. Let's talk about how I'm going to do that. As I said, I'll put this fixture for the rib in a vise, which I've done right here. And again, the rib will be riveted in here, and I'll rivet this little fitting out here. See. Then what I'll use is I'll use this basket here. Now this basket has some shackles attaching it to a weight sensor, and you can see the display for that sensor right here. So this fitting will fit through a hole here in the shackle. And now I've got a bunch of weights that I can put down here on this basket. And I'll put them on one at a time, reading the display, reading how much weight I put on here until we actually get this to fail. Now that's in one orientation. Again, I can turn this over for the other orientation. I can put this in here like this and put a weight out here and again, do a failure test. So my plan is to find out at what weight each of these designs fails at. That'll tell me how much moment they can handle before they fail. Once I get at least these three shapes tested, then I'll have to sit down and think about if these don't handle as much weight as I would like, what design changes am I going to have to make in order to get it better? More than likely, I'm just going to have to make this radius larger with a larger flange. And I'll have to keep increasing that until I get the strength that I want. Well, that's all I wanted to do in this video. I wanted to give you a plan for the part B of this video. And in part B, we'll figure out if there's going to be a part C. For a full rib test and design, I'll probably put that in a completely separate video. This is really just for the testing and analysis for a portion of the rib. Well, guys, that's it. Until next time.